I am Abhishek Tomar. I am Senior Principal Engineer at Angel One. Today I'm going to talk about disaster recovery. Basically handling the situation in case there is a disaster. It will be not very technical, but I will deep dive through some of the technical aspects of it. So guys, is there anyone in this room who trade in stock market or has placed any trade in stock market, crypto or anything? So now consider a situation that you have placed a trade or you have taken a position in stock market and there's a huge spike and app goes down, your trading app goes down. Now this is a disaster. This is what we see a lot in Indian stock markets or global stock markets. And this is probably because there is some whale who is manipulating the situations, hunting stop loss and handling these. But this is exactly what disaster is. Now disaster can happen because of multiple reasons. It's possible that there is fire somewhere in any other data center, or there is natural disaster, or maybe some developer pushing wrong config, or it's also possible that rats nibbling the data wires in the data center. There are multiple reasons, but overall it affects our system, and especially in case of banking systems and financial systems, stock broking system, there is a significant financial loss. Now, if your Facebook or Instagram is going down for some time, that's fine. But financial system, banks going down is a huge thing. So there can be reputational damage. There are instances where this kind of instances happen in past and companies has gone down. There is financial loss, as we discussed. There is data loss, downtime. Now coming to recovery. Now as an engineer, we build services. And while building services, we make sure that it's fault tolerant, reliable, highly available. We have defined architecture patterns, recipes around it, load balancer and those kind of things. But when you go for a system, the system is not a single service. It's may basically consist of hundreds or thousands of services which are working together. So these principles which work at a service level cannot work at a system level. So you need to have a process, or you need to have a playbook, you need to have architectural recipes across the organization in place so that you can handle these kind of disasters very soon. And you should be up within minutes. So that's what we will discuss here. So recovery, as I told you, recovery is taking care of such practices so that we are able to handle these situations very fast, because there is a significant financial loss for the clients. But not all kind of disaster can be handled. You can see in this meme. So Dan the dinosaur thought that he has handled all the disasters in his disaster recovery plan, but there are disasters which cannot be handled. Now coming to this is a big issue. Disaster recovery is a big thing across industry. So recently, for Meta, data center was down. They pushed some of the wrong configs in data center, and Facebook, Instagram, WhatsApp were down for like couple of hours. This is around a couple of months back. So I've put this meme from Twitter and I've put it here. But and also AWS, Azure, a lot of past services goes down here and there. Cloudflare goes down, internet services are interrupted. But if you see stock market, things are a bit different. I'll just walk you through this first example. So on 23rd February 2021, so Municipal Corporation of Mumbai was actually doing some digging outside of NSC office. So NSC has these lease lines to other data centers, and they end up digging all the lease lines coming into NSC. And stock market was down during the mid of the market, at around 12 or 1, market went down, and it went off for around 3 to 4 hours. It came down 4 p.m. in the evening. So this is a big thing, the stock market, the main stock exchange going down all of a sudden during a market. It's a big thing. And this is the reason there's a lot of regulations on stock market in terms of outages. So SEBI is the Security and Exchange Board of India. It actually released a circular and said that there needs to be constant drills. There needs to be DR happening in live. And this is heavily regulated. If there's an outage at a broker of like couple of like 10 minutes, 15 minutes, 20 minutes, then both internal and external RCAs needs to be done, and discussion goes for years. It's so much heavily regulated. This drills needs to be done quarterly. And systems are monitored very heavily. And this is not only for brokers, this is for exchange, depositories, clearing corporations, and all the participants in the stock market. Now, this is the integration for a typical broker. This is how integration looks like. If you see here, we connect to payment gateways, clearing corporations, SMS providers, Cloudflare, depositories, and these integrations are typically on HTTP, or we just dump files or take files from them. But the core integration or the more complex integration is with Exchange. So suppose if you have to open a broker house like Angel One or something, so you have to have lease lines connecting your private data center to Exchange data center. And these lease lines are physical lines from Airtel or Jio or something, which is 1 Gbps, 2 Gbps lines. And both the data centers are also very close. They are near to each other. Now, on each lease line, you can configure adapters, what we call as Exchange adapters. You can say, okay, in 2 Gbps, we want to have for cash market, we want to have adapter 1. FNO, we want to have adapter 2. And currency commodity, you can do this. You can go on a portal of the exchange and you can configure it. And each adapter can be like, I want to put 100 orders or 200 orders per second. That is something which you can configure. And blue one here is we also have a backup lease line. Suppose the main lease line goes down, we have a backup lease line. The failover is not manual, it's not automated. But overall, exchange integrations are pretty complex. And the data transferred here is in a proprietary format. It's a binary format, basically byte array, which we cut and read it. And it is over TCP, custom protocol called as trimmed protocol. This is at our system, this is the high level architecture diagram. So all our trading services, the ones which connects exchange, your order placement, positions and everything works in a private data center. All our non-transactional service like watch list, charts, search and everything works in public data center. Then there are back office. Back office basically end of the day jobs, which is nothing like Apache Spark jobs, DAG executions, which we work in AWS most of the times. Then we have apps, we have APIs, we have web, everything. A lot of things are built on top of our APIs. But overall, this is the architecture. Now, sharding wise, if you see the transactional services which I talked about, the order placement, when you place an order, it goes to exchange. We have created multiple shards. It's not a single big cluster or fleet which is doing the work. We have multiple shards. And in both the data centers, this is Mumbai data center, Chennai data center, and both the data centers are next to exchange data centers. So shard 1 is active here, shard, and its follower, which is inactive, is working there in the other data center. Similarly, for shard 3 and 4, which are leader there, these are the followers. And the users to these shards are mapped at the start of the day because exchange integrations are TCP connections. So you cannot move users to different shards during the market, because all the updates which order which has been placed from user will come from that particular TCP adapter only. So the advantage of this is blast radius control is there. So if this thing goes down, then at least 50% of users are not affected, not even for 1 second. Other thing is there is a confidence in deployments. So since both the data centers, both the clusters are active, so we can make sure that the software deployed version and everything is constant across both of them. Otherwise, typically what happens if you have an active cluster and a passive follower, then follower versions seems to lag. That is not the case. This is it. So the connectivity between exchange is crisscross. So this is exchange Mumbai, this is exchange Chennai. We have in Mumbai, we have in Chennai. So we have lease line in the same region, we have lease line in another region also. So suppose if something goes wrong, we can actually go to our adapter login config, and instead of Mumbai, we can connect to Chennai from anywhere. So it's a cross lease lines which we have. This is shown here. Green is the active, red is the passive. Right. So coming to tenant. So typically for DR is a big thing, because we have a number of services, microservices and processes running into a system. So we need to build some tenets or principles which we can follow. For example, our DR is one click. So we don't want to be fully automated. You just click on a button and all your DAG workflow, everything executes and everything happens. I'll walk you through the whole playbook. Our DR is pretty fast. 15 minutes is something which we have tested and we don't want to break it. We support multiple DR types. There's a full data center going down, we can support it. Single shard, which I talked about, we can do a DR. We can support exchange DR. Suppose the exchange is stopped in Mumbai and active in Chennai, we can support it. We have service level DR also. For example, your watchlist service goes down, we can support it. So all crisscross DRs we can happen. And now the data loss, this is very important because the connection to exchange is async. It's TCP, it's not HTTP calls. So suppose you send an order to Exchange and Exchange goes down, your order is lost. Exchange don't have that order, but we have that order in our system. So now when Exchange comes up, we will ask Exchange to give all the dump of all the orders and trades which had happened in Exchange for this particular adapter ID from the morning. And then we will reconcile and we will see, okay, these are the orders which which Exchange does not have and we should discard it. So data loss is there, state changes are there, our order will be, maybe our order is partially fulfilled, in Exchange it is fulfilled. So we want to detect these data losses as soon as possible and communicate to users that your orders might be lost, please replace your orders. On the engineering guidelines, this is the data sync approach. So when you have multiple data centers running, you need to sync your data. On the database, we have non-multi-master. This is master-slave architecture. So each cluster will have 4 nodes, master in data center 1, slave in data center 1. Then within same data center, slave is also there, which is getting synced in sync way, and other one is getting is async sync. So this is async. What you see here is async synchronization between both the data centers. But your data is getting synced across all the services. We have trade service, order service, risk management. All data is syncing in async way. Redis is something which you use for caching. This is very important because the load which we get on trade books, order books is very huge. So Redis is a multi-DC setup which we have done. It's a cluster setup. All our transactional data going to data lake and everything, it happens through Kafka in all the data centers. So we put everything in the local Kafka topics in that data center, and eventually it reaches in all 3 data centers, AWS and both the data centers, Mumbai and Chennai. This is an approach we follow in all services. No team in a company can come and say, okay, I don't want to follow this unless and until they have a valid reason. This is an engineering guideline. Service deployment. So typically active setup for our P0 services. Basically services are running in both the systems, and from DNS we are controlling where the traffic is flowing. But there are few things, for example, if you see charts, if you trade on Zerodha or anything, there is chart. And from chart, there are ticks which are continuously coming through WebSocket. So we do WebSocket. Now WebSocket management of 3 or 4 lakh clients is a huge thing. We have a huge fleet. And this data is a metadata. It's not a transactional data. So it is running live in both the data centers. When I say live is both the data centers, the traffic is going to both the data centers. No user mapping, WebSocket management. And from Exchange, we are getting UDP packets from their multicast server. We are using internal data structures and we are actually sending it to the WebSockets, whoever is interested in that data. And sharding approach, if it's a P0 service or if there is a limitation from Exchange, then shard it, otherwise don't shard it. If possible, move it to public cloud, otherwise put in private cloud. These are the guidelines which we follow to make our life simple and to maintain a continuity across the organization. Now now we'll go through the playbook. Suppose DR happen, what will happen? So this is the playbook we follow. So if DR happens, I show you the button, you will click the button. Your DNS will be flipped from your primary site to error server, and you will be shown this message that DR is progress, trading will be live soon. Basically, first thing we have to do is tell the customer that something is not right. Please don't expect things to work as it is. Please wait for some time. Second thing is Exchange login. This is what I explained. You have a cross connection. Our Mumbai data center is connecting to Exchange Mumbai data center, also in Chennai data center. So what we'll do is Exchange goes down in Mumbai. We will actually redo our login at our Mumbai data center to connect to NSC Chennai site. So this is a manual step. We cannot do it. It is not automatic. It's not an automatic failover. We will run the script with the correct arguments, and it will happen. CTCL ID here is the computer to computer link. So typically when you connect to Exchange, it's a direct computer to computer. We give our IP to Exchange. Exchange give our to IP to, we whitelisted, and it's a TCP connection. It's super fast. You can understand the lease line, so machines are so close to each other. It's a super fast communication. Third thing is config push and DB failover. So configs needs to be changed in few of the applications. Few of the application need to understand, for example, the cleanup jobs and all. They need to understand that that I am in this particular data center. In that case, we have to push the configs. DB failover, as I told, our DB is multi-master, so not multi-master. We have to do a manual failover across data centers. So for that also we have script. So we use Apache Airflow, GitHub Actions, We make the changes and this DAG is propagated across all our systems. Suppose there are 10 or 20 different services, its configs are changed and these configs are dynamically loaded into these instances. Data reconciliation, this is the most important thing which I touched upon. The data can be lost, as I told you, because it's async communication over TCP. It's not a HTTP call. So suppose for us order is in open state, at exchange it can be in the filled state. So exchange is the truth here. So when DR happens, we have made a new connection to exchange. We will tell exchange, give us all the data, whatever you have for all the customers in this particular adapter. They will provide everything over TCP, all the trades, orders. From trade and orders, we will join and we will create positions of the customers. And this data will create a DAG. So basically, trade service will do a reconciliation. It will discard everything which is not correct, which it is having but not at exchange. Order service will do it. Position service will come into picture, then portfolio service and all. This is a bottom-up reconciliation. So exchange is the truth. Then all the services which are on top of the stack will keep on handling this reconciliation and data correctness. There's service called as recon orchestrator. This recon orchestrator will wait for this DAG to complete and it will then tell the customer, it will then put out a signal that your data recon is complete. We are good to go now. At the end, we will just do a DNS flip. From error server, we will move to secondary side. Last thing is tell the customer, okay, we are back now after 5-10 minutes or whatever the downtime was. We will tell the customers that we are back now. You can please verify your orders because it's possible that your orders are lost or your positions may be incorrect. Then observability. Now when software systems are running into two data centers, now maintaining a gap between them, if there is a lag and measuring that lag is very important. So as I told you that we have Redis, which is our caching layer, and RMS here is a risk management system, which is basically core of any trading system. So, and these have in-memory data structures, which are getting synced over a channel across both the data centers. So suppose trading is happening in RMS primary, all the data is from in-memory data structures are getting synced in RMS secondary. And from there, it is going to a reader, most probably a Kafka. And from there, it is getting into Redis. So this is where trading is happening. Redis is correct. Data is eventually coming into this Redis in another data center. We are monitoring using Prometheus and the logs of writing to Redis. We are monitoring how much lag is there in the Redis. Basically, what is the difference of the key count or update count. And we are this is one of the core metric which we monitor. This gives a very idea that if there is a lag between both the systems or not. For DB and Kafka, so these clusters, the commercial databases, Confluent, Kafka, they automatically provide you these lag dashboards. So this is being taken care of. Deployment checks means at the night, we run version checks in both the systems. And if there is a version 1 in one data center and same service is running in version 2 in another data center, every night we run those checks and tell services that your versions are not correct. Please make sure your version should be same in both data centers. And then there is a consolidated dashboard. That's it, guys.